Welcome back, students. Now, before we could go to example 9.12, I would like you all to understand this question. We are given integral 0 to pi over 4 x times secant squared x dx. We expected to integrate this. Now, if you were to see this, it has got two functions. So one is algebraic, x is algebraic, and this one is trigonometric. Okay, so there are two functions there. So whenever you have two functions, we use what is called as integration by parts. So you have to use the law Liate, L-I-A-T-E. Now L stands for logarithmic function, I stands for inverse functions, A stands for algebraic functions. Now T stands for trigonometric functions. E stands for exponential functions. Okay, so depending upon this order, this is order 1, 2, 3, 4, 5, you have to assign the value for u. Now u is taken to be as, if you see, algebraic function comes before trigonometric function, so you have to take the substitution for u as x. Now why do I do this? Because we have this formula. Okay, so what is the formula do we have? The formula is integral u dv is equal to u times v minus integral v du. So this is the popular integration by parts formula, which you have to know. So whatever we got here, the first quantity, the first term is taken to be as u, and dv is taken to be as secant squared x dx. So to get v, I integrate. Okay, now when I integrate dv and secant squared x dx, integral of dv will give me v. Integration of secant squared x will give me tan x. Okay, we got a formula. So substituting, so therefore in the place of u, I have got x times secant squared x dx is now rewritten as x times, my v is tan x, the limits are 0 to pi divided by 4, negative, integral, my v is tan x, my du is dx, right? Because u is equal to x, so when you differentiate u, you get dx. So du is equal to dx. So this is what we have got. Now we are expected to integrate tan x. So I'm going to show you how to integrate tan x here. So we got tan x dx, but I can rewrite tan x to be as sin x over cos x times dx. Then I would substitute cos x to be equal to t. When I differentiate cos x, I get negative sin x to be equal to dt. Of course, I need to place dx there. So this is going to be negative dt, because we just have sin x dx, so I need to move this negative to the other side, and cos x is t. But integral of dt over t, we know that, because dx, integration of dx over x is equal to log x, positive constant c. So because of this formula, this is going to be negative log of t. But t is cos x, so this is going to be cos x. Okay, so we have got integral tan x dx to be as negative log cos x, positive constant c. So I would be using this quantity over here. So now this is going to be x times tan x, integral within the limit 0 to pi over 4, negative, in the place of integral 0 to pi over 4 tan x dx, I'm going to be substituting negative log of cos x. The limits are 0 to pi over 4. Now this is going to be equal to x times tan x, 0 to pi over 4, negative times negative will become positive. So you got log of cos x, the limits are 0 to pi over 4. So now I would be applying the limits. We get, when I apply the limits, we get the following. So apply the upper limit. So that's going to be pi over 4 times tan pi over 4 negative 0 times tan 0. And following it up with the second quantity, apply the limits. So it's going to be log of cos pi over 4 negative log of cos 0. Now this is equal to pi over 4. Now this is going to be tan 45. This one will get cancelled out. And this is going to be log of cos 45. And this is going to be cos of 0 is going to be 1. So this is going to get cancelled out. So you don't need to write this. Just for the sake of continuity, I'm writing it. So this is going to be pi over 4. Tan 45 is 1 plus log of cos 45. Cos 45 is 1 over root 2. So this is going to be log of 1 over root 2. So the final solution is pi divided by 4 positive log of 1 over root 2. So why did I do all this? Because I wanted you all to understand what happens when you have got a quantity like this, x times secant squared x dx. Of course, you can have any limits a to b. Depending upon the limits, the solution would vary.